So in this video, I will demonstrate the feature L3 VPN, MPLS L3 VPN feature that Vyos has recently started supporting. And for that, you would need the 1.4 rolling release or 1.4 release for this to work, because the previous videos I've made on 1.2, 1.1, and 1.3, but this one is 1.4, so make sure you have the 1.4 release for the PE routers at least. And this setup basically is going to demonstrate how the two CE routers, one right here as a customer edge router and one over here as a customer edge router, let's just say they're same customers and they're trying to exchange their networks across the MPLS network from a service provider or their own MPLS network that they own. And this site, the CE one, is advertising 100.111, and this site is advertising 200.444. And these will be exported and advertised to the PEs using eBGP. So CE2 is running eBGP, doing eBGP peering with PE2 VRF eBGP and an address family VRF. And on this side, CE1 is doing eBGP on the address family VRF on PE1, and I'll show you the configuration. So once this route is learned into this VRF, and we'll call it C1 in this case, this VRF is learned in a route distinguisher, and let's just say it's a routing bucket. It's a VPN routing buckets kept separately from the default routing table. Now, once you learn this route into this VRF, you got to put this route or routes into the VPN, because the VPN just exchanges labels using MPLS and LDP protocol. So they do not exchange or advertise routes for all the routers that are in the middle and connected in the core. So what they do is they do BGP peering, and they do it with iBGP. So in this case, PE1 and PE2 is doing iBGP peering, and they're using their loopback addresses to peer. The last video that I did on MPLS L3 VPN, I used Arista switches for PE1 and PE2 because Vyos didn't support it. Now Vyos is supporting it, so you don't need Arista switches to get your hands on it. Again, MPLS VPN L2 or L3 right now. The Vyos only supports L3 VPNs, so that's what I'm demonstrating. L3, we had two different subnets. With L2, it's going to be the same subnet getting extended, but in L3, there are two different subnets. So the protocol requirement for this is, again, on this side, on the CE side, you need BGP, eBGP peering with the PE, and the PE is going to use VRF on this interface. And on this interface, the PE is just going to enable MPLS LDP, and it's going to use its loopback /32 loopback address and this interface right here as MPLS LDP interfaces. Same with PE2. It's going to use its loopback /32 and this interface as MPLS LDP interfaces. They start exchanging LDP labels. They're going to use LDP protocol to exchange MPLS labels for each route that they learn in a specific VRF. And again, they're going to do iBGP peering between each other. In this setup, I'm using static routes to make sure that PE1 is able to reach this guy, and PE2 is able to reach this guy. Just simple static route. You can use OSPF if you want, and I would highly encourage that you do that by putting another router, putting another loopback, and make this interface, and this interface LDP, MPLS LDP capable, and enable OSPF, and then play with this. But to just keep this simple, a setup simple as possible. For demonstration, I've directly connected the two PEs together with the loopbacks, IBGP, MPLS LDP, and static routing to the loopbacks. The two PEs are part of AS23. The CE1 here is AS1. The CE2 here is AS4. Advertising these specific prefixes here, it's 100.1.1 going this way. This guy is advertising 200 going this way. So when this guy learns this prefix in this VRF, we're going to call it C1 VRF, he will have to put that VRF or redistribute that VRF into the VPN address family. And that's the complex configuration that comes in this. It's much more simpler in other platforms, but Vyos is, in my opinion, a little complex. But here, and again, the CE2 would advertise this route into C1, and C1 VRF would put this route into VPN address family, and then the VPN will exchange these routes using MPLS labels with the help of LDP protocol, label distribution protocol. So that's the setup, and I would pop up the routers to this is the CE1, and the CE1 looks pretty straightforward from a configuration perspective. Show interfaces. This interface is 12001 right here. I'm just eliminating all the labeling here just to keep it simple. This 12001 is facing this way. 100.1.1 is another interface, which is this guy right here. And then this is just the management interface. You can ignore that part. And this is also in the management interface. So let's look at the show protocol BGP. Very straightforward. Address family IPv4 unicast. Okay, so this is IPv4 unicast for global routing table. Just redistributing connected, which basically means I'm redistributing this address and this address in local AS BGP AS1, and my neighbor is 2002, which is this guy right here, and this guy is going to be in Vrf C1, and I'll show you the PE1 configuration. That's all there is on this router. Let's look at the PE1 router. PE1 router, that's peering. We're just focusing on eBGP and Vrf configuration, so let's look at that. Run show interface. You see the interface is 1202 is right here compared to 12001 that we saw. (12.0.0.1), 12.0.0.2. Show interface, and he's part of Vrf C1 right here. It's pretty straightforward. Now let's look at the BGP configuration. Uh, 2302 is this guy right here. So, and he's got MPLS LDP labels, and we'll see that. Let's look at the BGP configuration on the PE1 facing CE1. Show protocol BGP. That's about it. It's got local AS23, and address family is remote as it. This is the this is the address family VPN v4. So we have to look at, remember how this guy's in VRF. So we have to look at the VRF configuration. So this configuration that you're looking at, it's facing this way towards the other PE. So this is to look at the configuration that's facing towards the CE. You're going to have to see show VRF, and that is the VRF configuration that looks fairly detailed and complex. The components here is, again, you define the VRF by giving it a name, C1 in this case, and then go into protocol BGP. So if you have to do set protocol BGP and there is no VRF here, so you have to go set VRF name C1 protocol BGP. That's the confusing part or in Vyos here. So let's look at the components that's facing the CE protocol BGP inside the VRF configuration called C1. Address family is IPv4 unicast facing this one, because this is still in the IPv4 non-VPN address family. So, but we are in VRF. Here are ton loads of exports and imports, and basically what you're saying is you're going to export this into a VPN address family, and then you're saying I'm going to import as well and export both. So I'm exporting and importing this C1 routes that I'm learning from here. I'm exporting them and importing them. So if you don't want to export and import, you can do that. But in our case, we're exporting and importing. And then we're using label VPN labels that is automatically selected. We're not choosing any specific label numbers, which you can do if you want for the LDP protocol. But we're just saying auto. And then the route distinguisher here, we just choose the AS number, which is the local AS number for the MPLS cloud, and then the number that is unique to the customer. In this case, customer 1, customer 2, or whatever you want to make it. But both of the sites needs to be matching up here, and I'll put the config side by side. Redistribute connected. Route target is for filtering again, but in our case, we're importing everything and exporting everything that's related to AS23 and customer 1. And it's part of the local AS23, and I'm neighboring 12001. So this is again facing this side, VRF side, and it's IPv4 unicast, right? And then you also have to specify the table, routing table number for the VRF. So this is looks pretty complex. It is complex, but you gotta put in this configuration for the VRF part facing the CE side. Now the PE to PE side is pretty straightforward, and you're gonna go do the same thing on this PE2 side facing CE2. Let me show you the PE to PE. Let's see which one is my 3. This is my 3 right here. So now let's look at PE to PE facing BGP configuration. Show protocol BGP, right? This is again the VPN facing the PE. Show protocol BGP. That's pretty straightforward. Basically, I'm pointing to the loopbacks of each other in an address family VPN. And I'm saying use my loopback as an update source, and your VPN neighbor relationship should come up as long as you do show protocol MPLS. You got to do this part as well for the MPLS part. So BGP is straightforward, facing facing the P's facing each other is pretty straightforward. But now the MPLS part is where they're exchanging the labels, learning and distributing the labels using LDP. So you got to do the MPLS LDP part, include the interfaces, And this command is necessary to make sure this is your own local loopback, not the other side's loopback. And as long as you put in this stuff correctly with router IDs, and in our case, we're using two interfaces, loopback and Ethernet 1 facing each other. That's the PE routers facing each other. This is the configs for PE routers facing each other, and that's about it. And once you do that, let me put up the VRF side by side so that you can see. It's pretty identical, and you got to put it on both PEs that are facing or neighboring with the CE router. So this guy is facing this with this CE1, and this PE2 is facing the CE2. And once you do that, your MPLS should come up. You can verify all of that stuff. But let's take a look at the route. The global routing table has no routes, both sides, but this guy has BGP routes coming from the other CE 200, right? So let's go to my PE4. Show IP route. I'm learning 100, which is a connected route here. I'm learning this route as BGP, and my connected route is getting learned as BGP here. But in these PE routers, I don't have these routes in the global routing table. They only show up in the VRF routing table. Right here. 12 and 100, 200 and 100. Okay. This one is not coming clean with all the label information, so you're going to have to adjust your window size accordingly to see it clean. But the global routing table does not have these routes, and these routes are exchanged through MPLS labels here, as you can see. Let's test the connectivity to 100 right here, or 200, sorry, BGP 200. There you go. And if you want to use your loopback interface, which is 100, or not loopback, your local interface for pinging, you can do that too. Since I'm doing read distribute connected, they're getting all the connected routes information as well. My local is 100, so I'm going to say 100. There you go. So this is how the Vyos is supporting the L3 VPNs. If you look at the show IP BGP summary, it'll give you the prefixes that are learned from the CE side. The interface, the neighbor, and the interface, the prefixes that it's learning. And for show IP, show BGP, VRF, all C, when we just do C. And it's very confusing, to say the least, that it does not show anything here, because I'm doing the VRF part, but it should be showing me something, but it doesn't. But I think they're still trying to fix some of this stuff, but it works. It at least works from a CE to CE routing perspective. Some of the show commands are extremely confusing, but that's where you have to kind of get your hands on and understand what this guy Vyos is doing. Hope this helps and in learning how MPLS concepts are deployed in the real world. Hope this helps.